Namaste. Welcome to PABSON Distant Learning Education Program, collaboration with Janata Television. This is grade 9 science, and today we will continue the previous one that we have discussed momentum previously. So momentum we have defined as the mass into velocity. That is the product of mass and velocity we have defined as a momentum, and the unit of momentum mass unit is kg and the velocity is meter per second square. That's why kg meter per second is the SI unit for the momentum, and it's a vector quantity that we have learned previously. So today we will discuss some numerical problem related to this momentum. So let's see. Question is like this: calculate the momentum of a car with 900 kg and moving with the velocity of 30 meter per second. So this question you can see on the screen also. So let's calculate the momentum. So here, what is given there? There is given mass of a car. So symbol I will write down small m is given 900 kg. Similarly, velocity is given there. Velocity of a car, so symbol I will write down v, it is given about 30 meter per second, right? And momentum, so momentum we need to calculate, right? And momentum we will write down p, that is watt. So we have the formula of momentum we have learned is P equals to m into v, right? Mass into velocity, and mass we have 900 and velocity we have 30. So this is 27, 1, 2 and 3. This is kg meter per second is the answer. Therefore, momentum of that car is 27,000 kg meter per second. So related with this momentum, we can solve the numerical problem by using this formula. Okay, so let's move on to next topic, that is called Newton's law of motion. So let's see about the Newton's law of motion. Newton's law of motion. So to describe the motion of an object, the Newton, he formulated the three laws, which is popularly known as Newton's law of motion. First, Newton's first law of motion, Newton's second law of motion, and the Newton's third law of motion is the three law which is used to describe the motions of any object. So we are going to discuss about this three laws of a motion, which is known as the Newton's law of a motion. And this Newton's law of motion specially relate the force applied on the object and the motion of a object. Especially it deals with the force as well as the motion of a body. So let's discuss the first law of motion, Newton's first law of motion. First one, Newton's first law of motion. So what this Newton's first law of motion says is, everybody continue to be the state of rest or to be the state of motion until and unless an unbalanced force act on it, which is the Newton's first law of motion. What that means is, suppose I have the one object here in my hand, and this object is now initially at the rest, right? And when I apply the unbalanced force on it, then it comes in the motion. That means when the unbalanced force act on the object, then it changes the state of the object from the rest to motion, and from the motion to rest. That is known as a Newton's first law of motion, right? And this Newton's first law of motion, it is also known as the law of inertia also, because it is related with the inertia. Inertia is the property of the body to retain its own state. Either that may be in the rest or either that may be in the motion. That we have learned inertia of rest, inertia of motion, and the inertia of direction also we have discussed one. So this first law of motion, it is also known as the law of inertia also. And similarly, this first law of motion gives the definitions of a force also. Force, we have learned, it is the external agent which changes or tends to change the state of object from rest to motion or from motion to rest. That means the definition of force is defined with the help of this Newton's first law of motion. Example of this Newton's first law of motion that explained is whenever we switch off the electric fan that is in the motion state, it tries to remain in the motion, and due to the frictional force it comes in the rest. Similarly, when we run, suddenly we cannot come in the rest position. That is also related with this first Newton's first law of motion. So I think the concept is clear. Next one is Newton's second law of motion is there. So before stating this Newton's second law of motion, so let me give one example. Suppose this object is there. If I push this object with the less force, the object moves slowly. That means the acceleration produced on it is less, right? If I push this very hardly, then the acceleration produced on it is more. Similarly, if I push the small object with some certain amount of force, the velocity or accelerations may more over there. If I put the big object and if I apply the force, same amount of force, then the accelerations will be decreased over there. What I mean is the acceleration produced in the object, for example, whenever we apply the force, then acceleration is produced over there, right? Acceleration produced in the object is directly proportional with the applied force and inversely proportional with the mass. If there is more mass, then the less acceleration is produced. If there is less mass, then more acceleration is produced. Similarly, if you apply the more amount of force, more acceleration is produced. If you apply the less amount of force, then less acceleration is produced. That's why the acceleration which is produced on the object or a body is directly proportional with the force applied and inversely proportional with the mass, which is the Newton's second law of motion. And this Newton's second law of motion, it gives the measurement of force. That means we can calculate the force with the help of this F equals to ma, and this F equals to ma is given by the Newton's second law of motion, right? Newton's second law of motion. That's why the measurement of force is with the help of this Newton's second law of motion. So let's derive this F equals to ma. So how to derive this F equals to ma? So let's see. So let's derive this. Let F be the force applied in a body of mass m which produce acceleration of a. Let's say small a. It is the acceleration produced when the F force is applied on the object with the mass m, right? Now according to the Newton's second law of motion, what it says, the acceleration produced in a body is directly proportional with the force applied one, right? That means, so from Newton's second law of motion, acceleration produced in a body is directly proportional proportional to force applied. Force applied. That is, acceleration produced is directly proportional to the force applied. So this is equation 1. I have already said the acceleration which is produced on the object, right, by applying the force, that is directly proportional with the force applied one, right. Similarly, the acceleration produced in the object is inversely proportional with the mass. That also we have learned. So again, so this acceleration produced is inversely proportional with the mass of an object. So this I will write down equation 2nd. So from equation 1st and 2nd, so let me rub this. So from equation 1 and 2, right, then what we will get here is A is proportional with the F but inversely proportional with the mass. This is combination of equation 1 and 2, right. So let's simplify this. Or F is proportional with A and M. So let me reverse this, M and A, right. So there is proportional sign is there. We need to remove this proportional sign for the simplification one. That's why or F equals to K M A, where K is proportionality constant, right. Now if F equals to 1 Newton I apply, right, and the mass I take 1 kg, and if it produces the accelerations of 1 meter per second square, if you put these values here, then that will be 1 equals to K into 1 into 1. Therefore, K equals to 1. So let's put the value of this K on this equation 3rd, right. Then we get F equals to M into A, which is the 2nd law of motion. So force is the product of mass into acceleration produced on the object. That's why the 2nd law of motion, it gives the measurement of a force. First law of motion, it gives the definition of force, and the 2nd law of motion, it gives the measurement of a force. So this is the derivations, that is F equals to ma. Now let's define the 1 Newton force. So how we can define this 1 Newton force? Let's see. So how we can define this 1 Newton force? This 1 Newton force, it is the amount of force applied on the object of 1 kg to accelerate the 1 meter per second square. That means if I apply the 1 Newton force, then 1 kg object get accelerated by the 1 meter per second square. So let's define this. 1 Newton force is amount of force that apply in 1 kg object to produce acceleration of 1 meter per second square. So this is the amount of force which cause the productions of acceleration of 1 meter per second square when we apply that in the 1 kg object. So this is 1 Newton force. Okay. So let's see some numerical problem related to this 2nd law of motion. So question you can see on the screen. The question is, a cricket ball of mass 70 kg moving with the velocity of 0.5 meter per second is stopped by a players in 0.5 second. What force is applied by the player to stop the ball? That is a numerical problem. So let's solve this one. Here, mass is given over there. Mass, so I'll write down the small m, is 70 gram is there. 70 gram. So this gram, it is in CGS system of unit. So let's change this into the MKS system of unit or SI system of unit. So this 70 divided by 1000. This is 0.07 kg. Okay, this and this cancel. That means 0.07 kg, right? Similarly, the velocity is given over there. Initial velocity is there. Initial velocity. So symbol is U, is 0.5 meter per second, and it comes in the rest. That means final velocity. Final velocity. So this I'll write down this V is 0 meter per second because it comes in the rest, right? And the time taken is there. Time taken. Symbol is T. The time is given over there. 0.5 second is there, right? And we need to calculate the force applied by the player to stop the ball. So force F equals to what? We need to calculate the force. So we have to calculate the force, and the formula of force just previously we have derived. F equals to m into a, right? Mass is already here and acceleration is not there. So with the help of this parameter, we need to calculate the accelerations of a object. So now, so we have to find the acceleration first. So acceleration A equals to V minus U by T. This is the formula that we have learned previously, right? So V is here 0, U is here minus 0.5, and T is here 0.5. So equals to minus 0.5 by 0.5. If you cancel this, it is minus 1. So acceleration is there. That's why it is a meter per second square, right? Again, now we have the formula F equals to m into a. Mass is here. It is 0.07 and acceleration is minus 1 is here, right? It is a retardation, so we need to mention this minus also. Therefore, minus F, it is the retarding force it is called. So this will be 0.07 Newton. So the retarding force applied on that ball is 0.07 Newton to comes in the rest. So like this we can solve the numerical problem. Similarly, another one more numerical problem we have. So number 2. So let's see that numerical problem also. The numerical problem is like this. A bus, its mass is given 900 kg, right? It's moving with the velocity of 60 km per hour, and if it is stopped at a distance of 50 meter by applying a brakes, calculate the force required to stop the bus. Here also we need to calculate the force, right? So let's list out firstly the given. So here is given mass of car, right? So mass of bus is there. I will write down this small m. It is 900 kg is there, right? Similarly, the initial velocity is there. Initial velocity. So I will write down this small u. The initial velocity is there, 60 km per hour. This is in this is not in SI system of unit, so we need to change this into SI system of unit, right? So let's change this one. 60 and kilometer into meter multiply by 1000, and hour is there. If you multiply this by 60, that will be in the minute, right? And if you again multiply this by 60, then that will be in the second. So if you cancel this, let's cancel this also. This will be 100 by 6 meter per second, right? Okay. Then after it brakes applies is there. That means final velocity. So I will write down this by V equals to 0 meter per second. Why? Because brake is applied and finally the bus, it comes in the rest. That's why the final velocity is 0 meter per second, right? And the distance covered here, distance covered. So this distance covered is S, and there is given the 50 meter. Before coming in the rest, the 50 meter distance is traveled one. So we need to calculate here force applied. Symbol is F equals to what? So in this case also, for calculating the force, we need to know the acceleration, right? And we use this 3 component to calculate the acceleration. Okay, so I think you might have remembered the formula. The formula is you can write down this V equals to U plus AT, right? Similarly, S equals to U plus V by 2 into T also. S equals to UT plus half AT square, right? And similarly, you can say V square equals to U square plus 2A. S. So these formula you have learned previously, that is the equations of motion, right? And in this equation of motion, so there is no time taken here. Time taken is missing there, so we can use the formula which doesn't contain the time. That means here in this formula there is time is there, so we cannot use this. Here time is there, we cannot use this, and here also time is there, we cannot use this. That's why this formula is suitable for calculating the acceleration in this case, because time is not here and time is not here. That's why this formula we will use. So we have the formula is V square equals to U square plus 2AS. So V square, it's a 0 is there, 0 square equals to U is there 50 to the square plus 2. Acceleration we need to calculate. So A, and the distance is there 50, right? So or minus 100A equals to 2500, or minus A equals to 2500 divided by 100. That is 25 meter per second square. Therefore, retardation equals to 25 meter per second square. Now we need to calculate the force. Now F equals to m into A. Mass is there 900 kg, so equals to 900 into acceleration, it is retardation, so we will mention that negative value also here, that is minus 25. So it gives the 900 into minus 25, let's multiply that. 900 into 25, that gives the minus 22500 is the answer. Therefore, retarding force, so you can write down here minus F equals to 22500 Newton. So we can write down here retarding force equals to 22,500 Newton is the answer. So 2 comes in the rest by applying the brake. 22,500 Newton force should be applied one to bring this bus into the rest. So by this process we can solve the numerical problem related with the second law of motion, Newton's second law of motion. So last one law, that is called the third law of motion. Newton's third law of motion. So Newton's third law of motion. So this Newton's third law of motion, whenever we hit the wall with the help of our hand, right? If you hit slowly, then we feel less pain, right? So what I said is, when I hit the wall with the help of my hand, if I hit slowly, then less pain is felt by our hand, right? Similarly, if I hit the wall very hardly, then we will feel the more pain here. That means whatever force we applied on the wall, whatever force my hand applied on the wall, same amount of force is applied by the wall to my hand. That means every action, there is equal and opposite reaction. This is the statement for the third law, Newton's third law of motion. What I have said, to every action there is equal but opposite reactions are there, which is known as the third law of Newton's third law of motion. So you can see on the screen, there is I have kept the two pictures over there. So whenever we walk, right, our leg is there. That leg is pushing the ground in the downward direction. That is the action. The force applied by our leg to the ground, it is the action. And on the same time, the ground also applies a certain amount of force to our leg, which is the reaction. So in this case, action is the force applied to the ground, and the reaction is force applied by the ground to our leg. That is the reaction, right? Similarly, whenever we push the wall, then we are applying the force to the wall. That is the action, right? Similarly, the wall also pushing by certain force to our body, which is the reaction one. So remember that action and the reaction, they are equal and the opposite in the direction, and they are applied completely in the two different objects. So in this case, you can see here the force applied to the wall, that is the action, right? The force applied to our body, that is the reaction one. So action and reaction, they lies completely two different objects. Similarly, if you put the book in the table, right? Suppose this one is book, suppose, right? And whenever you put the book in the table, then the weight is there, right? The weight act in the downward direction, vertically downward direction, that is the action, right? And same amount of force which is applied by the book to the table in the downward direction, same amount of force is applied by the table to the book also, which is the reaction one. So weight, it is the action, and the force exerted by the table to the book, that is the reaction one. Okay. So some in our day-to-day life, the different events are there which are based on this Newton's third law of motion. So let's explain some of them. So whenever we swim, then we use our hand to push the water in the backward direction, and in that condition our body get move in the forward direction. When we push the water in the backward direction, then our body move in the forward direction. That is also due to the third law of motion. So whenever we push the water in the backward direction, that pushing of water in the backward direction, that is the action, right? And the same amount of force is applied by the water to our body, which is the reaction. And due to this reaction, we move in the forward direction, right? Okay, lastly, the one video is there. You can see here, right? The one person is shooting with the help of gun, right? So, and the gun get recoiled, which cause the falling of that person. This is also due to the third law of motion. So how this related is, whenever the trigger is there, when the trigger strike the bullet, then the bullet get the force by the trigger, that is the action, which cause the movement of the bullet in the forward direction. And on the same time, the bullet also apply the same amount of force to the gun, which is the reaction one. And due to the backward movement of the gun, by the force of the bullet, the gun get recoil after the fired. This is also third law of motion. So today we have discussed the different laws of the Newton's law of motion, that is first law of motion, second law of motion, and the third law of motion, right? And some more example you can find in your textbook also about this third law of motion. So get prepared about this third law of motion. In next class we'll discuss more about this third law of motion. So thank you very much for joining the class. Thank you very much, everyone.